The 2-pound brick slides down a smooth roof with a velocity v sub a is given in this direction, and the total height, if you see from here to this brick, is 30 plus 15. So also the slope is given here 3, 4, 5, and find the speed when it is at location B, and find the distance or the range of the projectile from this location B to C, and also find the speed when it lands on the floor or the ground at location C. So I'm going to start from this work and energy principle. So T1 plus sigma u 1 to 2 gives you T2. Now here 1 represents A, so I will say let's do this application on position A, from A to B. This is B, okay. So now this is a smooth roof, so there is no friction present, so only the force acting on it is the gravity, the weight acting downward. And you have already seen that the distance, which is equal to W times delta H, which is from A to B, since we are considering not from A to C but from A to B. That's why we are not taking the whole distance from the floor but from this location B. So that's why I'm going to use U due to gravity is W times delta H. Now you will tell me that if the gravity is acting down and the brick is also moving downward, so would it be positive or negative work done? Positive, because both are going downward. So mg, m is 2 pounds, sorry, this is the W, is it? Yeah, it's a 2 pound, it's in British system. Delta H is 15 inches, so 30, sorry, not inches but 30 foot-pound. This is the work done due to the gravity, and there is no other force acting on it. The gravity is bringing the brick down. Agreed? We have done this portion. Let's see TA. If you are given with the initial speed, can you find out the kinetic energy at location A? M is, now M is different than 2 because 2 pound is the weight, so M equals to W over G, 2 over, now G in FPS system is 32.2. VA is given, which is 5 squared. So what do you get? So if you take a look, it is 0.77 foot-pound. And the right hand side, let's complete this equation again. Left hand side, I'm going to write down 0.77 for this equation. Let's equation 1. Let's fill in all the places here. Plus 30 half m VB square. So if you solve one equation, one unknown, if you solve for V sub B, you should get 31.48 feet per second. So you see how easy it is to use the work energy principle to find out the speed of the second point, second location. You will use the same principle to find out the speed of this point. So let's use the same principle. Now this time I'm using point A and point C. T sub A plus half mv sub A square equals to, sorry, not equals to, but I'm sorry what I'm doing here. This is U 1 to 2, U sub W, T sub C. So this is correct now. So let's use this again. So T sub A is already there, so we don't need to recalculate it. This is 0.77 but UW is little bit changed. W times the delta H is changed now. You have to consider the total depth or total height from the floor to the location. So this is 30 plus 15. That is equals to 45. So it is equal to 2 times 45 equals to half m. It is 32.2 VC square. So one unknown, one equation. So if you solve for this, you should get 54.1 feet per second. This is correct because this is greater than VB. Now the third part is asking what is the range of the projectile if it lands at location C. Find out the distance D. So I mentioned this is a chapter 12 question we did in our chapter 12. So let me grab this again. Let me grab this from figure again to show you on our next section here. So I want to show you that if the velocity B is in this direction, which is V sub B, and and can you tell me what is the, if this is a 3, 4, 5, what is VBX? That is more important because you know this formula is the final the distance formula. I just wrote down the distance formula here. X equal to x naught plus v naught x t. This is the general formula, but for our case this is the d. X is replaced by d equals to x naught, which is 0 in our case. VBX times the time. Now the time can be found from another equation of the distance formula. So but VBX, you already know that this is 4/5 times the velocity, which is 31.48. Agreed? This is the horizontal direction. And now in order to find out this time, let's use the distance formula for the y direction. Now here, if you consider this is the point B and this is point C, this is my datum line. So going down is -30 because from B to C you have to go -30 feet down, and y0 is 0. V sub y, VB sub y or V sub by, it is 3/5. Agreed? Sorry, this is the velocity, which is how much? VB is 31.48 times t, and then negative times half g is 32.2. Now here comes the equation here I want to mention. Can you solve for this? What is the distance here? So one thing I want to mention, that upward in this case is positive. That's why we have a negative sign due to the gravity which is acting downward, and negative sign due to the position which is from B to C. Now this question is clear. If you solve for t, you should get 0.9 seconds, almost 0.899 or 0.9. So now you can plug this t over here. So if I bring this equation number 2 here, d equals to what? D equals to, I would say d equals to 4/5 times 31.48 times 0.9, which is 22.6 feet. So this is your answer.